Hi all. So in this video we'll be seeing about the signal AW burst. AW burst kind of tells you how the address is going to change from beat to beat, and we have different types of burst. So that is what explicitly this particular signal tells us about. So it is a 2-bit signal. So let us now see the encoding for the AW burst 2-bit signal. So 00 means fixed, 01 means incremental, 10 is RAM, and 11 is reserved. So in case of the fixed, the address kind of stays the same for every beat. In case of the incremental, as the name suggests, the address keeps on incrementing for every beat by the transfer size. And in case of wrap, the address increments just like the INCR, but it wraps within the boundary. So now let us explore each of these bursts in more detail. So in case of the fixed burst, so the address does not change and every data beat writes to the same address. So here the address is always constant for every clock cycle. The typical use cases for these are the FIFOs, peripheral registers, and any APB based devices. Let us take a small example. Let us say the AW size is 4 bytes, length is 3, which means 4 bits, and AW address is 1000. So since there are 4 beats and the starting address is 1000, we see that it starts at 1000. But for even all the remaining beats, the address remains constant and does not increment. So this is the in case of the fixed burst. Now we shall move over to the incremental burst. So in case of the incremental burst, the address increments by the AW size every beat. So this is for any linear memory access, right? And typical use cases for any DDR or SRAM access, cache line fills, and any normal memory writes, we kind of use this incremental burst. So mainly more for the DDR or SRAM and any normal memory writes. Let us take a small example here. So the AW size is the same example, where the AW size is 4, length is 3, and address is 1000. But here you see that it gets incremented for every cycle. The starting address is 1000, and the very next cycle, we see that since the AW size is like 4 bytes, the address moves on to 1004. Consider this is a byte addressable memory for my byte addressable end target. So the incremental addresses are starting from 1000, 1004, 1008, and 100C, each getting incremented by the AW size, which is 4 bytes. So these are the 4 beats in case of the incremental burst. Now moving on to the wrap burst, here too the address increments, but when the boundary is reached, it wraps around. So how do we know the wrap size? The wrap size is given by AW plus 1 into 2 power AW size. So boundary rule. So the boundary rule is that the start address must be aligned to the wrap size. And the typical use cases are for cache lines in any circular buffers. These are the wrap burst is typically used. So when we take the same example here, AW size is 4 and AW length is 3. The wrap size, as we already saw, AW length plus 1, which is like 4 bits, and the size is 4 bytes. So the wrap size comes to 16 bytes. And let us say the starting address is 1008. So 1008, the typical aligned address, it will start from 1000. So since there are 4 beats, it starts from 1008, goes to 1000C, and then after 1000C, it has to wrap around 1000, and then it again increments 1004. So here we see that all the 4 addresses are within the wrap boundary and doesn't cross this particular address, which is aligned to the AW size. So here we see the range is from the 100 to 1000C plus 4 bytes. So this is the range in which we see that all the addresses are. So this is a glimpse of what is wrap burst is all about. Yeah, so just to wrap around. So And these are some important points we should always keep in mind. The increment and wrap burst must not cross the 4K boundary, but the fixed burst can cross the 4K boundary. Since in case of the fixed, we are going using the same address, so there is no kind of limit on the cross boundary. But in case of the other two, we see that we have this cross boundary condition of 4K. And yeah, so in case of AXI 3, we can go up to 16 beats, and AXI 4 up to 256 beats. So these are some side notes, but hope you understood all the important points with respect to the AWBurst. Thank you.